Here's our lesson on solving equations with x on both sides, part 2. Okay, and as usual, we'll start with our definition of solve, which is to find all values of x that make the equation true. Okay, example 1, they want us to solve these. Let's have a look at A. A is exactly like the questions from part 1. We'll just go over it for a review of what we've already learned. You guys hopefully remember from last lesson that we need to get all of the x's on both sides first. Well, that it's a good idea to anyways. And that we want to get them on the side with the greater number of x's. So in this case, we've got negative 3 x's here, negative 2 there. Negative 2 is greater than negative 3, so we want to get all the x's on this side, which means we want to get rid of the negative 3x on this side. So I'm going to add 3x to both sides. Negative 3x plus 3x is 0, so that's a 5. And we've got negative 2x plus 3x is x, minus 1. Just about done. We just need to add 1 now to both sides to get x by itself. I get 4 equals x. And now let's make sure that when x equals 4, the equation is true. I'm going to write it exactly the same as the original, but instead of x, I'm going to put in a 4 in brackets. Okay, over here I'm going to do the multiplying first, so I've got negative 12 plus 5. Multiplying first on this side, negative 8 minus 1, which gives me negative 12 plus 5. Negative 7. Okay, what the heck? I got negative 7 equals negative 9. Oh, I was supposed to add 1 to both sides there. There we go. So that should have been 6. Okay, well, hey, you know what? I'm going to leave this in the video because as I always tell you guys, if you get to the end and you get something that doesn't equal, then you need to go back and see where you made your mistake. I can see now that this is where I made my mistake. So that should have been x equals 6. Okay, let's go back and do our check again. And so we notice that this check didn't work. Let's do another check with x equals 6. We've got negative 3 times 6 plus 5 equals negative 2 times 6 minus 1. Got negative 18 plus 5 equals negative 12 minus 1. Negative 13 equals negative 13 is true. Oops, let me just slide that up a bit more so you guys can see it. Perfect, got a nice lefty smudge there on the 3. Okay, so now we know that when x equals 6, our equation is true. And we also know what to do when we do a check and we don't get the left side equaling the right side. We go back and figure out what we did wrong. Perfect. Okay, let's have a look at B. Okay, so again, we want to get the x's on the same side, and we want it to be the side with the greater number of x's. Well, 4 is greater than 2, so let's get rid of this 2x. I'm going to subtract 2x from both sides. 2x minus 2x is 0. So that's a 5. 4x minus 2x is 2x. Minus 3. And now I need to add 3 to both sides. Get 8 equals 2x. Divide both sides by 2 because we want 1 times x. So 8 divided by 2 is 4. 2 divided by 2 is 1, so I got 1 times x, or just x. Okay, and now let's make sure that that makes the original equation true. Write it exactly the same as the original, but instead of x, I'm going to put a 4 in brackets. So I've got 8 plus 5 equals 16 minus 3. 13 equals 13 is true. That makes me happy after getting that first one wrong. Okay, good. Next one, C. So C, we're going to have to think back to the stuff we learned in polynomials and simplify this a bit before we can start trying to solve it. So first thing we want to do on the left is we've got y's here and we've got y's there. So you remember in the polynomials unit we would give those the same shape. In this case I'm going to underline both of them. Got negative 7y plus 2y is going to be negative 5y, and the 3 is still just a 3. And now over here we're going to want to multiply this negative 3 into the brackets. So I'll get negative 8 minus 3y. Negative 3 times negative 1 is plus 3. Okay, and we can still simplify the right side a bit. We can combine the negative 8 and the plus 3. So the left side isn't going to change, so I'm just going to rewrite that. And then over here I'll have minus 3y, and then negative 3y, I should say, and then negative 8 plus 3 is negative 5. Okay, and now this looks a lot like questions we've seen before. Okay, so we want to get the y's on one side and the side with the greater number of y's, which is going to be this side. So I'm going to add 5y to both sides. Negative 5y plus 5y is 0, so that's just 3. Negative 3y plus 5y is 2y, minus 5. Add 5 to both sides, I get 8 equals 2y. Divide both sides by 2, I get 4 equals y. Okay, and again, remember, we need to check this in the original equation. So I'm going to write it out exactly the same as the original, but instead of y, I'm going to have a 4 in brackets. Okay, here we go. So now we've got lots of bed mass, order of operations stuff to do. I'm going to do all of the multiplying on the left side first. And then on the right side we want to do the brackets first. Okay, the left side we can just add all those up. And what's that going to give us? Negative 17. And on the right side we want to do the multiplying now. Left side is still negative 17. And the right side simplifies to negative 17. So we did it right again. So after getting the first one wrong, I'm 2 for 2. Feel pretty proud of myself. Okay, next one, D. Where's D? There it is. Okay, and again we want to get w's on the side with the greatest number of w's. In this case that's this side. So we're going to subtract 2w from both sides. Get 3w minus 3 equals 7. Add 3 to both sides. I got 3w equals 10. And then divide both sides by 3. So I get w equals 10 over 3. And I recommend you leave this as an improper fraction, because the first thing we're going to do when we substitute it in is multiply. And it's much easier to multiply an improper fraction. Okay, so let's do our check here. We're going to write it exactly the same as the original, but instead of w, we're going to write 10 over 3 in brackets. Okay, multiplying fractions is pretty easy. We can think about this 5 as 5 over 1, and we're just going to go top times top, bottom times bottom. So we're going to end up with 50 over 3. That's still just a minus 3. And actually, let's write the minus 3 as minus 3 over 1, just to kind of plan ahead for the fact that we're going to be subtracting these. Do the same thing on the other side. That's 2 over 1. So I end up with 20 over 3. Plus 7 over 1. Okay, and now I'm going to want common denominators of 3 on both sides, so I can do that adding and subtracting. So 50 over 3. I'm going to multiply top and bottom here by 3, so that's going to give me 9 over 3. Push that up a bit there. Oops. Equals 20 over 3 plus multiply top and bottom by 3 is going to be 21 over 3, which is going to give me 41 over 3 equals 41 over 3. All right, doing much better since that first question. Okay, so we know that when w equals 10 over 3, the equation is true, so that's our solution. Okay, and we've just got 2 more here. Okay, E. We've got 3x plus 2 equals negative 3x plus 3. Huh. So we've got the same number of x's on both sides. So I guess it doesn't matter which one we get rid of. Let's subtract 3x from both sides. So we get 0 plus 2 equals negative 3 plus 0. Oh, weird. End up with 2 equals negative 3. Okay, let's go back and think about our definition of solve here. You remember solve, we need to find all values of x that are going to make this equation true. Well, no matter what I put in for x here, this 3x and that 3x is going to be the same. So for example, if I put in x equals 1, those are both going to be 3. If I put in x equals 0, they're both going to be 0. But no matter what I put in for x, the left side is always going to be 5 more than the right side. Right? Like if I put in 0 here for x, I'd get 2 equals negative 3, which is obviously not true because the left side is going to be 5 more. If I put in x equals 1, I'd get 5 equals 0. Again, the left side is going to be 5 more than the right side, and that's always going to be the case. So there's no values of x that are going to make this true. So we say no solution. There are no values of x that will make it true, so we have no solution. Okay, let's have a look at f. F looks pretty similar here, but a little bit different. So let's again start by subtracting 3x from both sides. And this time I end up with 2 equals 2. Which is true. And again, let's think about what happens if I put in different things for x here. So if I put in x equals 0, I'd get 2 equals 2. That's true. If I put in x equals 1, I'd get 5 equals 5. That's true. If I put in x equals 2, what's that going to be? 3 times 2 is 6, plus 2 is 8. I'd end up with 8 equals 8. That's true. So in this case, it doesn't matter what x is. It's always true. So in math, if we want to say x can be anything, we can say x is a real number. And if you want to write that in fancy math speak, you can say that x is an element. We use a lowercase epsilon there. And then we use an r with the double line on the left there to show real numbers. So depending on how you want to write it, if you want to be fancy, you can write x as an element of the reals, or you can just write x as a real number, which basically means x can be anything, and it'll still make the equation true. Okay, so notice, if all of the x's go away and we end up with something that's always false, then it doesn't matter what x is, it's always going to be false. We get no solution. If all the x's go away and we end up with something that's always true, it doesn't matter what x is, it's always true. So x can be anything, which means that the solution is that x is just any number, or a real number is how we say it. Okay, that's all. Enjoy.